Hey, this question was on Fall 15 Exam 2, and I just want to show everybody. So people did really, really well on the F double prime. So I'll do that one first. Okay, I'll zoom in a little bit. Okay, so the neat thing about this one is I'm glad people actually figured out what concavity is all about. So if you're driving along on your car, if you're driving and your car is this way, you know, your little headlights are going out that way, and you're flat on the road, and this is the road you're driving on, okay? Then when your steering wheel is straight, like right here your steering wheel is straight, you're going from curving to the right and you're now curving to the left. And then this happens again here, you're curving to the left and then you switch to curving to the right. And I'm actually going to turn my screen around, you can't see that I'm doing that, but I'm driving this way like that, and then I'm curving to the right, and right about here it's flat. I don't really care if you say it's here or here, but don't give me three of them. There's only one point at which you're going to claim that your steering wheel straightens out. And so these points are roughly here, and you know, I don't care exactly where you place them, so you know, like we can just stick that right on the integer if we want. I don't really care about that because this exercise isn't that sensitive. So I can put them right here so they're on integers, and then just say, all right, that's where my points of inflection look like they are. And so I'm going to just split at 2, 4, and say 7. So now this part looks like an umbrella, and it's spilling water, so that would be negative. This part also looks like an umbrella, that's the negative. And then here it's going up, it's a cup. 2 to 4 is also a cup. So that's fine. Okay, I'm going to leave that other thing there. It's kind of hard to erase that. Okay, so that was actually pretty well answered by most people. I'm just going to actually erase all this stuff because I want to write on here again. I want to talk about the first derivative, and the first derivative is simply going up or down. And here is a max. Now this is called a relative max. Over here is your absolute max, and only like 1 or 2 people figured that out. I didn't take off if you didn't figure it out because I didn't really emphasize that in class. But this is another relative max, and this guy is a relative min. So these should be labeled as maxes and mins, and this guy is the absolute max and a relative relative min and an absolute min. Okay, so there's inside here, some people thought this was the absolute max because their eye kind of cut this off, and that's okay, that's forgivable. I mean, you should be a little more careful, but so should I. Okay, so the cut points are here, 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 and again, if you want to make them close to something convenient, I made this 1, 3, 5, 8.5, because it's not really yet 9. And so I'm going to make it 1, 3, 5, and maybe 8.5. And then they just alternate, right? So we start by going up, so car's going up, it's positive, and from there down to the relative min, it's negative. This just is going to alternate. Nothing weird is going on here. And so it just goes up, down, up, down, up. Okay, and that would be full credit. And if you prefer, remember in the answer key I had said x and then type. I had said what's going on at each x value. So I'm going to say at x equals 1 we have a max, and at x equals 3 we have a min, and x equals 5 we have a max, and x equals 8.5 we have a min, and I guess x equals 10 we should be saying we have a max. That's an absolute max. Okay, and then drop in the PIs. Points of inflection is where the concavity switches. So at 2 we have a PI, at 4 we have a PI, and at 7 we have a PI. And that would have been optional if it were already labeled on the graph itself. So either one of those would have been fine.